Hey, good afternoon or good morning, everybody. My name is Benton Cook with Double Radius. We are going to give it a couple minutes to allow some more people to jump in, and then we'll get started in just a minute or two. Appreciate everybody joining us. All right, we'll give everybody another minute or two to get a couple extra late stragglers to join us, and then we will get started. All right, I show about 3 after, so we'll go ahead and get rolling. I'm sure we'll have a couple extra stragglers join us. But again, everybody, welcome. Thank you so much for joining us. Good afternoon, good morning, depending on the time zone. My name is Benton Cook. I am with Double Radius. Quick little overview of who I am, who we are, and who ICT is, and then I'll hand it over to the stars of the show. Again, my name is Benton, Double Radius. We are a master distributor of all things fixed wireless, as well as fixed wireless accessories, whether it be cable, whether it be power, whether it be tower supplies. We have been in business since 2001. We are super excited about this one. We have started a new partnership with ICT. Today's webinar, Power Your Site with DC, is going to go through a few steps on how to configure a DC power system. With us today from ICT, we have Cliff Mandel and Charles Klein. What I'll do is I'll just kind of give both of them a quick second to not only introduce themselves, but introduce ICT, and then Cliff's going to dive into the slideshow. I think I'm very excited about this partnership and about ICT, mainly because it is a product that I have plenty of customers who are using, and I think there's a lot of people that are going to be able to take away a lot of knowledge from this, because DC power is obviously the way to go for a lot of you guys, for a lot of the operators out there. So if you're not using DC, we highly recommend reaching out to us, reaching out to ICT. But I'll go ahead and hand it over to Charles Klein. Charles, if you don't mind, introduce yourself, introduce ICT.
Absolutely. Thank you, Benton. My name is Charles, and for those of you to help pronounce that, it is like Carl, but with an SH in front of it. And if all else fails, please call me Char. I am with ICT, and I am the channel distribution manager, and I work directly with Double Radius. And we are very excited with this partnership. We see that it's a perfect fit for what Double Radius is bringing to you already, and a nice extension to your power. ICT is a manufacturer of DC power conversion products, and we are 100% North American manufactured. We are a leader in affordable TCP/IP remote DC power management solutions. And what that means to you is that we are trying to save you site visits by giving you remote access and control right on your cell phone, tablet, desktop, whatever you prefer to manage your DC sites with. Without further ado, I will pass you over to Cliff. Cliff has many, many years of experience with DC power. He is a great go-to when you're configuring your DC system, as well as you can reach out to me through Double Radius as well. And after the presentation, if you have more questions about our particular products and more about the features and benefits of the site configurations, please reach out to us and we'll be more than happy to do a little bit more of a custom breakdown for you.
Yeah, and real quick, Cliff, before you take over, Charles, I'm glad you said that. For everybody who's in attendance, we do want this to be as interactive as possible. So obviously Cliff's going to be going through his slides, but there is a box on your panel that shows for questions. If you have any questions throughout, please put them in there. I'll be interjecting when need be. And then at the end, if we have questions that haven't been answered, we'll definitely reach those. But if you do have questions throughout the presentation, please feel free to put them into the question box. Cliff, I'll let you take it away from here, my friend.
Okay, thank you very much, Benton. Thank you, Charles. Hello, everybody. I'm Cliff Mandel. I'm the Business Development Manager here at ICT. I've been with the company coming up on 7 years. Been selling power supplies for longer than I want to admit. And I do have an engineering background, and I'm also active in applications. And one of the things that I do is I help customers design an appropriate DC power budget for their sites. Usually they end up being large, medium, and small sites. And what I'm going to do is when I go through this presentation, I'm going to show you how I do that. There are certain questions that I usually ask. So here's what it says: 5 steps to configure a DC power system. So that's what I'm going to go through for you guys. And again, like if you have any questions, feel free to text them in, and you know, I'll be happy to answer those as we go, or perhaps at the end of the presentation. So why isn't my slide working? Oh, this is great.
Of course, we did a test run before this and everything worked perfect, but you know, showtime, Cliff, and here we are.
It's not working. I can't get to the next slide. Oh.
And while Cliff is doing that, just a shout out to everybody to let you know that Double Radius and ICT will also be at Whisperpalooza next week in Vegas. If you happen to be there, please drop by and see us.
I guess the pointer that I had was interrupting the advance. So can you see my mouse moving around? That'll work as a pointer.
Yes, sir, you're good.
Okay, good. So this is just a little background on the company and the markets that we are involved in. So basically, we've been in business about 35 years, and we got our start in the land mobile radio business, and we're providing DC power for public safety, state and local agencies, resource exploration, utilities, transportation. These are critical applications where if the radios don't work, then people's lives are in danger. So the real emphasis here is on high reliability. And then about 10 years ago, 15 years ago, I guess we got involved in fixed wireless broadband, and that's taken off like a big rocket, as you guys probably know. So we're providing DC power solutions for the wireless internet service providers for the WISP market. And that's been a tremendous market for us, and we've done very well. And we've partnered with some of the largest WISPs in the country, and they're, if you've done any research and talked to any of them, you'll see what the things that they say about us. So we're involved in the rural broadband development. We're also working with fiber head end deployment, and we're also providing DC power for their distributed antenna systems, and also the radio access network and small cell applications. And the industrial power, we're involved in SCADA telemetry and building DC power, renewable energy systems, and security and surveillance. And but it's the fixed wireless broadband market that's really been a really great market for us. A lot of the customers that I'm dealing with have been using a system that's a UPS system. And so what we're trying to show you here is that by switching over to direct DC, you're going to save a lot in efficiencies. So this is a typical UPS system. We've got an AC source that's going into a rectifier / charger, and it's converting that AC into DC. The DC is charging the battery, and then we're taking that current out of the battery and we're putting it into inverter and changing it from DC back into AC. And then that AC is going into a AC PDU and powering the load. So there's a lot of steps here, and each time we have a step, we lose efficiency. And so the power that you have at the beginning is going to be greatly reduced by the time you get to the end. Plus, you've got a lot of so-called moving parts. There's more things to go wrong. But the modern LTE radios, the backhaul radios often require neg 48, and DC power systems eliminate the inverter and the switch, providing fewer parts, reducing potential failures. And plus, we can offer advanced battery management to help monitor and control the battery, and offering alarm notification and state of charge remaining battery runtime with our intelligent battery management system. Here's an example. So when I'm talking to a customer, the first thing I ask them, how much power do you need for a site? And you'd be surprised how many people don't know the answer to this. And so what I try to do is I try to get them to send us a BOM list of all of the parts that would go into a typical site for their large sites and for their medium sites. And what you're seeing here is an actual customer's requirement. And so you can see we've got mixed voltages and mixed polarities. We're calculating the max power based on, what is this radio or this device going to draw when it's full power? And then the number of devices, how many of these are PoE? How many loads do you have for this particular site? Is there any AC at the site? And then the total PoE power that's required. And then we come up with a budget that's, in this case, it's 2,622 watts at this particular large site. And then we're looking at their medium sites, and a similar thing is going on, but there are fewer components, and so we end up with less power. And so what we can do is we can, specify the correct DC power configuration for each one of these sites, so that you don't end up buying more than what you need, and you get enough so that you won't end up drawing power off the battery and then not having any power when the AC goes offline. So that's really the important thing here as well. And so when we're talking about the large sites, we end up with 2,622 watts. And so this is what I would estimate to be a solution would be using our modular power series ICT2U5, and I'll show you what that looks like later on. And then these are our power modules, 700 watt power modules, which is 5 of them. And then we'd also use the 200 dB12 dual bus distribution panel with 12 outputs. And then we'd have a variety of different breakers that would be installed in the distribution panel. And then there's an inverter here, probably powering one of the AC devices. And let's see, where's that? It's probably the router. The MikroTik router is probably going to be using that AC current. And so then we talk about battery, and we're going to get into that here as we get further along. And in this case, we're saying that if you're using a 400 amp hour AGM battery, it'll provide about 4.5 hours of runtime and take about 14 hours to recharge the battery. So in this case, you might want to use a dual string battery with two 200 amp hour battery strings in order to give you this runtime. So, but remembering and keeping in mind that the runtime is a worst case scenario based on everything running at full power at the same time. So this number is going to be better in real life, and this number also will be lower as far as the recharge time. And if you're thinking about a lithium battery, we have a bit, our software has been configured to accept lithium batteries, and so it would take about half the amount of energy to give you the same amount of hours, because the lithium battery can run all the way down to the shut off, whereas a AGM battery usually is about 50% before you need to shut the battery off to avoid a deep discharge. And so these are some of the companies that have been using some of our products, and so this is what it would look like for the medium site. Has 1427 watts. This is the solution at ICT, IPS, BMMD, which is our 1U modular power series using 3 700 watt power modules, and then a DC-DC converter, an inverter, and then the rack mount kit. So we're going to talk about polarity here because it's certainly a subject that comes up often when I'm talking to customers, and some of them, a lot of customers don't understand, what's all this neg 48 business and what's that all about. So neg 48 has been a typical voltage that's been used by telco for many years, and now it's starting to become more popular in the fixed wireless broadband market, as a lot of the higher power radios are sort of more into the carrier grade, and so they're using neg 48. And so in a neg 48 system, the load is carried on the negative terminal and the return is on the positive terminal. And those are the things to really keep in mind, is the load and return rather than plus, minus, or red and black. If you keep in mind load and return, and I can show you what that looks like in a wiring diagram, you're less likely to get it wrong. But then in a plus 48 system is called negative ground. So the negative 48 is positive ground, or it's negative voltage, positive voltage, negative ground. So the plus 48 DC is like your car. It's got the load on the plus side and the return on the negative side. Keeping in mind that all the devices are connected to the DC power source need to have the same polarity as the DC power source. So it's either neg 48 or plus 48. And the important thing here is to avoid mixing polarities connected to the same power source. That's where you let the smoke out. And that's the thing that we really, really want to try to avoid. And that's why we provide these services here, to make sure that when you hook up your devices to our power plants, everything runs smoothly and there's no issues with short circuits or popping breakers or anything like that. So here's a wiring diagram, an example using our modular power series. This is what it would look like in a typical neg 48 system. So when you see the battery, try to imagine that there are 4 batteries here connected in series in order to provide that 48 volt output. In this case, the load is on the negative side of the battery, and it's wired into BAT minus, or the minus terminal of the battery. And the positive is connected to the positive output in the rectifier, and the negative is connected to the negative or the load. So in other words, the energy is going in this direction. So this is providing the neg 48, and then the positive is reference to ground, is 0 volts that goes into the plus side of the battery. And then if we have a plus 48 system, then the opposite is true, where the plus side of the battery is carrying the load. We've got a fuse here between the battery and the rectifier. The rectifier is BAT plus, and then the minus side is the return. So in this case, it's just the opposite as this one. We have the energy going, the loads going to the plus side of the device, and the negative side is the return, reference to ground, okay? And then this is our MPS Ultra, and here you can see a dual string battery. So there's 4 batteries here and 4 batteries here. And so in this case, it's neg 48. So the negative terminal of the battery is connected to BAT 1 minus, and the negative terminal of the second string is BAT 2 minus. And then, as we saw before, the plus side of the battery is connected together, and then plus goes into positive, and negative is carrying the load. So the energy is going in this direction and the return is going this way and is referenced to ground. So that's why when we say negative voltage, positive ground, that's where that comes from right here. And then the opposite is true if you have a plus 48 system. So the plus side of the battery is battery 1 plus and battery 2 plus are the two strings. And then the positive terminal is carrying the load, and then the return is the negative, and thus negative is referenced to ground here. So we have positive voltage, negative ground in this particular configuration. So when you're connecting third-party equipment, it's really important to note the polarity of the device's input. And I often getting in touch with the manufacturers of the components that you guys are using in your sites, trying to determine whether the loads required by that radio or switch or that router or whatever it happens to be, what's the polarity of it? Because sometimes they don't tell you. And sometimes they'll just say, oh, it's just a 48 volt DC, and they're not putting a polarity symbol. So this could mean, you know, two or three things. It could mean the device's input is isolated and either polarity will work, and it could be either plus or neg 48, and they've left the symbol out. So that's often the case, but you don't want to take that for granted. An isolated input means that neither the positive nor the negative input is any reference to ground, or we also refer to that as being agnostic. And if you're not sure, you can actually conduct your own continuity test by using an ohm meter and connecting setting the ohm meter to show the continuity, and then having it buzz when you connect the probes together. And you would connect, and on the back of the device, you could connect the ground lug to the plus and the ground lug to the minus alternatively. And if you don't hear any buzz, then you know that the device, the radio, the switch, the router, whatever, is agnostic or plus minus. It doesn't matter. But we need to determine what does it say in the data sheet and what is it actually doing. So here you can see a negative earth example. And so this would be where the load is carried on the plus side of the battery. So it's positive voltage, negative ground, like your car, for example. So in this case, the load's going this way, and there's a switch, or you could even imagine that there would be a fuse or a breaker here, and then the load is carried to the bottom. In this case, the bulb, and then on the negative side is reference to ground, which is reference to ground on the battery, and this is just the opposite, showing positive earth. And so in this case, the negative side of the battery is carrying the load, so this would be negative voltage, positive ground. And so your load's going in this direction up to the bottom of the light bulb, and then the shell of the light bulb is reference to ground together with the plus side of the battery. So as long as the load and return is the same, you're in good shape. And this is an example of what that would look like. So we've got one probe connected to the ground lug on this particular device, and the other could be alternatively connected to the plus and the minus side of the output of the device. And if you don't hear any buzzing going on, then the device is floating or agnostic. And if one of them buzzes, then that'll give you an indication as to whether it's a positive voltage negative ground or negative voltage positive ground. Here's an example of a wiring diagram. This is using our modular power series together with our 200 dB12 distribution panel and dual bus panel. So in this case, this is an example of a negative 48 with dual string batteries. So the negative side is connected to with a fuse or a breaker here to battery 1 minus, and the negative terminal of the second string is battery 2 minus. So essentially these batteries are going to be running in parallel. So the strings are in series. You've got two series strings, and those strings are connected in parallel. And basically what this does, would double your runtime, but also keeping in mind it's also going to double the amount of time it's going to take to recharge the battery, right? So the plus side is going to be the return. This is where the load. So the load is going into the input of the distribution panel, and they're jumpered together between bus A and bus B. So that means this entire panel is going to be neg 48. And then the return, since these are connected internally, is coming back and connected to the positive terminal of the rectifier. And then when we're connecting the loads through the distribution panel, the output is going to the negative terminal of the device, and the return, which is referenced to ground, is going into RTN return. So it's pretty hard to get it wrong, but we want to just absolutely make sure that all the bases are covered and everything is clear. The important thing is to determine what is the requirement of the load device, the radio, the switch, the router, whatever you're powering, is what's the polarity requirement for it. So I just want to say one more thing here. The thing that I found, looking at all the components that most of my WISP customers are using, finding a device that's specifically positive voltage, negative ground is pretty rare. I've only found a couple of devices that require that. Most of them are agnostic, they're floating, but some of the higher end devices that are more carrier grade products are specifically neg 48, negative voltage, positive ground. That tends to be the common thing that I've been finding. So the next question I'm asking the customer is, do you need redundant power? What does it mean? What does N+1 mean? So N is the number of power modules that are required to meet the load's power requirement, and 1 is an extra module that's needed to provide redundancy. So the place that would be that you'd be looking for this sort of thing would be in backhaul sites or remote sites that are difficult to access, mountaintop repeaters, sites that take 3 or 4 hours to get to, or mission critical sites. If that site went down, the whole network would go down. That's where you should think about having redundancy with the power module. So in this case, we're doing a little bit of math here, and we're trying to determine how many power modules that it's going to take to, when we have 22 watts, 2,622 watts. If each of the rectifiers is 700 watts, how many will you need? So we divide the 2622 by 700, and I think we get a little over 3. And so in this case, you would need 4 power modules for your N, and the 5th power module would be your +1. So once you determine how many rectifiers that are required, then the redundancy is going to be that +1 rectifier. Now, the idea here behind this is that should one of the rectifiers go offline for whatever reason, you would get a notice, you would get an alarm notice, and it would send you an email, and it would let you know that one of the rectifiers has gone offline. But the remaining rectifiers, in this case, there would be 5 rectifiers altogether. And if one of them went offline, the remaining rectifiers would continue to power the load until you could send a technician out to the site and replace that one unit that had gone offline. And so that means that your site would keep operating and your customers wouldn't know the difference. And you just pull out, you pop out, because they're hot swap rectifiers, you could just pop out the one rectifier that had the red LED is glowing and pop in another one, and you're back in business. But you didn't suffer any downtime at the site.
Hey, Cliff, real quick.
Sure.
Quick question. What is the time frame that the other rectifiers will pick up the load? And is there a time frame where it automatically will try to switch back, or does it just run until it stops, or is it until it's fixed?
Okay. In a situation where the AC is still in operation, and so the rectifier is still providing DC power, and if it loses one of the power modules, the other power modules will automatically carry that load, because the way we've designed it is we've over-designed it so that those rectifiers, even though there's only 4 of them, would still be plenty to power the load. If, however, down the road, the customer decided to throw a whole bunch more radios on the tower and didn't do anything to upgrade his rectifier, once the AC went down, if there was more power that was required, it would draw power off the battery. So your site would still keep operating. It wouldn't be the best scenario because if there was actually a power outage and the AC went offline, in that sort of situation, you may find that your battery doesn't have the same capacity that you assumed that it did, because you've been drawing power off the battery all this while. And then, when the situation was with the AC offline, you may find that you would have a lot less runtime than you had assumed. So if you are adding more radios or more devices to the tower, you need to also consider your power budget, and you may need to add a power module to the system in order to be able to compensate for extra power. I hope that helped answer the question. If not, let me know. So the next session here is talking about DC distribution. So would the site require either a single bus or a dual bus distribution panel? A single bus panel would have single voltage only, and obviously a dual bus would be capable of providing two separate voltage or different polarities at the same site. This is a subject that I'm going to be talking about in depth and detail at Wispapalooza on Thursday morning. So if you're going to be there and you have a chance, you should come and take in that session. It's around 9 o'clock on Thursday morning. I'm going to talk about using different voltages and different polarities at the same site, which is what this is here. So if we have a dual bus panel, you could have plus 48 and neg 48, or you could have neg 48 and plus 24 at the same site by the way you wire and configure a DC-DC converter that would be isolated, that would go in between the rectifier, the neg 48 rectifier, and bus B, for example, in the distribution panel. Also, you'd want to look for TCP/IP Ethernet communications in the distribution panel. Our unit has that. We were one of the originators of this technology about 10 years ago, and it's become very, very popular with customers who want to have complete monitoring and control capabilities of each individual output. So I think Charles mentioned earlier, we have the ability to control each individual load without any disruption of the loads in the system. So what this does is it helps to reduce truck rolls and increases reliability, less network downtime, happy customers. It also is going to have the potential of saving money. So if you've got a remote site that's on the top of a mountain and you have to use a snowcat or a helicopter to get up there just to power cycle one device that got hung up, you can do that remotely. And that only has to happen a couple of times and you've already paid for the hardware. We also have features such as independent load shedding for each load, which means that each load has an LVD capability, a low voltage disconnect. So you can automatically turn off critical loads when the battery backup to extend the life of the runtime for critical loads. So if you've got a device like a camera or something that the site is not, it's not critical, you could set the voltage, the load shedding voltage higher on that device. So when you were running on battery, when it reached that voltage, it would shut that device off and give you more energy from your battery to be able to run the critical loads longer. We also have a feature called a network watchdog, which would ping the IP address of say a switch or a router to automatically power cycle that device if it gets hung up. So you know that if you lose your router, you've lost your comms. You have no ability to be able to communicate with the site. But the network watchdog is internal between the rectifier and the device. And so it would automatically reboot that device and you'd set up the parameters as to how much time it would take for that to happen in the outputs, in the controls, in the GUI control for the distribution panel. Now we talk about battery sizing. This is a question that I get asked many times when I'm talking to customers, and they're really interested in understanding this. And so I'm going to go through this. It's kind of basic, so forgive me if you guys are experts in this, but a lot of people are not. So amp hour tells you how much current a battery can provide over a certain period of time. So amps is designated with A multiplied by time, H. So if, for example, if you have a 100 amp hour battery, you can theoretically provide 100 amps for an hour, or 50 amps for 2 hours, or 25 amps for 4 hours, etc. But the best practice is to generally to double the required size of your battery. If you're using a lead acid battery, you're usually only going to get about 50% of this rating. So, for example, a 100 amp hour battery is only going to give you about actually 50 amp hours of time of power. And that's the reason for that is because the lead acid battery does not like to be deep discharged. And what you need to do is you need to check with your battery manufacturer to find out where you need to set the LVD, the low voltage disconnect for the battery. It depends on how often your site goes down, how often you need to use the battery. For example, if you live in Florida and you get thunderstorms every night in the summertime, you're going to have a lot more times when the AC is going to go down. So you'd want to set that LVD a little bit higher. But if you live like where we do in the Pacific Northwest, where we get, maybe one storm a year, then you'd probably want to set this a little bit higher, or you'd want to use maybe 60 or 70% of the battery before you hit the LVD, so you get longer run time, but fewer cycles. So there's only so much water in the bucket. But like I said here, be sure to check with the battery manufacturer to determine the best LVD setting for the system based on your environment. So this is going to get into the nitty gritty of how to determine the power requirements for your site. So the large site example, in this case, we're going to use 1140 watts, and we're going to convert that power using this formula, I equals P over V, where I is amps and P is power and V is voltage. So I is 1140 watts divided by 55.2. 55.2, and people say, where's that? Where does that come from? The upper voltage limit, the charge limit on most lead acid batteries is 13.8, I believe. And so if you take that and multiply it by 4, you get 55.2. So 55.2 is going to be the upper voltage limit of a charged lead acid battery. So if we do this formula, we come up with 21 amps. And so 21 amps is how much current the site requires with all the devices running at full load, right? Which is not going to happen very often, but when we design a system, we're designing it to the worst case scenario. And then we need to decide how much backup time you require for your site. So an average, let's use an average of 8 hours. So let's say a customer says, I need to have 8 hours of runtime. So we take the amp hour times the hours, so 21 times 8, that means 168 amp hours is what's going to be required to power this site with 1140 watts for 8 hours. So now we need to determine, the battery spec, and it's usually best practice, as I mentioned earlier, to double the required amp hours so that the battery is not completely depleted. So if we multiply 168 times 2, we get 336 amp hours, which means we're going to need a lead acid battery that's about 336 amp hours. And that, obviously we probably have to round that up to whatever's available. Now we want to determine how long it's going to take to recharge that battery based on the power supply. So if we assume we have 3 700-watt power modules, 3 times 700 is 2100 watts. That's how much the rectifier is going to give you. And if we divided that by 55.2, we end up with 38 amps. And so now if we take the load, the 1140 divided by, as we did earlier, 55.2, we get 21 amps. And now dividing the available amp hour, if we take 1/2 of the battery amp hour rating, 168 amp hours from, and now in order to determine how much it's going to, how long it's going to take, the load is 21 amps. So we subtract 21 from 38. 38 amps is from the rectifier. We end up with 17 amps. That's how much power we have available to recharge the battery. So if we take 17 divided by 168, we end up with about 10 hours to recharge the battery. And as I mentioned earlier, these numbers are ballpark numbers, and they're based on worst case scenarios. So often, if everything's healthy, if the battery's healthy, and you're not, and your loads aren't running 100% all the time, these numbers will be better. But it gets us in the ballpark. So now we're talking about what are the available options. So we're looking at the MPS Ultra here. The MPS Ultra is hot swap N+1 redundant rectifier for larger sites. When I'm talking about larger sites, that's for most of the WISP customers that I'm working with. And so it can give you from 1400 watts to 5600 watts with high reliability for mission critical sites, including breaker protected distribution. And so in this case, you've got 12 breaker protected outputs. Each one of these breakers is capable of 30 amp peak and 25 amp continuous. And then you've got dual string intelligent battery management here for 2 strings of 48 volt batteries and 4 700 watt power modules that are hot swappable. And a lot of our customers are using this based on their, if they're using this much power, where 3 power modules are their N, and the fourth one is the +1. They're often going with this device in order to be able to reduce the battery recharge time. That's something to consider. Then if you've got sort of a medium power situation, then you can use our 1U modular power series together with our distribution series 3 dual bus panel. So in that case, it's still N+1, but for medium power. In this case, it would be like for a 10 amp site. And then the second would be your +1. And then you could have a dual string battery management and then distribution, or you could take the distribution out, move the battery over to this slot and have another power module here if that's what you needed. So that's the advantage of having the modular system. You've also got intelligent battery management and TCP/IP Ethernet for remote monitoring and control with which each one of the outputs, and a separate Ethernet enabled DC distribution panel with the same features. Here's a new product that we just recently introduced. If you have a site that requires multiple voltages and multiple polarities at the same site, again, this is something I'll be discussing next week. This is our hybrid series modular rectifier, and it contains 48 volt rectifiers, and it also has a built-in 48 to 24 or 48 to 12, depending on your requirements, DC-DC converter, built right into the system. So in other words, if you had a site that was like a 10 amp site, again, you have N+1, and then you also have a 24 volt supply. You could wire the 48, the neg 48 rectifiers into bus A of the distribution panel, and you can wire the 24 volt DC-DC converter into bus B. You'd have 6 breaker protected outputs for neg 48 and 6 breaker protected outputs for +24 in the same distribution panel. Very convenient. As far as I know, I don't think there's anybody else that has this. I haven't seen any of our competitors that have anything that's even close to this. If you've got moderate sites that may not necessarily need N+1, if you need a power supply, we have our Platinum series, which can offer either 800 watts or 1600 watts. The beauty about this device is that it has a lot of the same features that is available in our modular power series. It just does not have the N+1 capability. So it's got TCP/IP Ethernet, it's got remote monitoring and control, it has advanced battery management, and I'll also add that these rectifiers are compatible with either lead acid or lithium batteries, and that's all set up in the GUI. So all you need to do when you're setting up the GUI, you can just click on either lead acid or lithium, and the software will configure the power supply to whichever one that you set. And then this is, again, our dual bus distribution panel for remote monitoring and control for each individual output. Temperature compensated charging is also built in for all of these products with built-in low voltage disconnect. And that's all programmable through the GUI. And then for smaller sites, for pico sites or repeater sites, or maybe a pole mounted enclosure that's got, DIN rail products, we have our IntelliCharge, which is a great product. And if your requirements are 400 watts or less, it has 3-stage battery charging, built-in low voltage disconnect, DIN rail adapter, user selector for flooded AGM or gel type batteries. It's got Form C alarm contacts. So if you hook this up with for example, with a distribution panel like this one that's got communications, you could wire it up from the alarm C contacts and into the back of the distribution panel, and it'll send you an alarm notice when the system has gone offline and is running off the battery. It also has temperature compensated charging capabilities, and you can use either the DC distribution or a PoE injector for distribution. That's probably going to be the more popular selection is a PoE injector. Here's a typical scenario for a site configuration. It shows a solar panel and then a solar charge controller that's charging the battery. And then in this case, there's a generator, and that obviously there's power from the grid. So the 110, 220 voltage is coming in here. In this case, we show Platinum Series. It's converting that AC into DC, and then the DC is going into a dual bus panel. So our neg 48 is going into bus A, and the DC-DC converter, then a separate converter, is converting that neg 48 into plus 24 because it's an isolated converter. So we have plus 24 coming out of bus B. So these 6 outputs are 24 volts that could be powering a PoE injector or a PoE controller or IP cameras or a GPS module, any of these devices that are running off 24 volts. And then you've got direct neg 48 that are powering these higher power radios. And then let's say you've got some AC product and either a router or Ethernet switch that's running off of AC. So we'd take that neg 48, we'd go into our inverter. It would convert that neg 48 into 120 volts AC that would power these 2 devices. And then that's,
And real
all
quick,
visible. Sure, go ahead.
Yeah, real quick, Cliff. I
Yep.
saw, it just was brought to my attention. I didn't realize that one of the attendees had their hand raised for a good amount of time, and I apologize. I did not see it. But it looked like Emil Butcher. Emil, I'm not sure if we're going to be able to hear you, sir, but if you want to go ahead and type your question into the question box, we'll make sure that Cliff gets on it. And it seems like 1 or 2 hands are raised right now. So if you guys could type it into the question box or the chat box, I'll make sure that Cliff gets a chance to answer it.
Okay, I know Butch. Yeah, he's one of our customers, so he's a good guy. So hi, Butch. Hope everything is well. Hope to see you next week. So here's an example of our GUI. I think I'm going to go into a little more detail with that if I'm not mistaken later on. But what I wanted to do is show you some site configuration examples. So these are always good to see. This is from one of our customers who's using our MPS Ultra. You can see he's got 6 700 watt power modules here and distribution. There's no battery management module here because he's got a big UPS that's backing this up. And this is for their data center. So data centers are always a good application. Here's the same customer. They're down in California, and they're using our MPS Ultra with 5 power modules, the battery management module, and 2 distribution modules here, along with 4 dual bus distribution panels with fuses. And he's using this, and I think this is for a fiber head end, if I'm not mistaken. Here's another look. This is for a customer that's using our MPS Ultra with 5 power modules and our front access distribution panel with 8 breaker protected outputs. and this is for a fiber head end. You can see the big old ad trend down there. So, this is one of our customers in, I think they're in New Orleans. Here's another one that's from our customer in California that's using their MPS Ultra with 5 power modules. And you can clearly see the distribution modules here and the battery management. And you can see the 300-watt inverter right here sitting on the top. And he's obviously powering a router from this inverter. Here's another example. This is from Whisper ISP. You probably know these guys. They're one of our largest accounts. So this is the front of the site, and this is the rear of the same site. So you can see this is our modular power series. And I was speaking sort of briefly about this application. The 3 power modules would easily give them N+1. But they went with the MPS Ultra with 4 power modules in order to reduce the amount of time that it would take to recharge the battery. So that's why we need to, try to get that information from you guys to find out how much time you actually need for battery run time. That way.
And real quick,
sure.
We do have a question real quick.
Okay.
Do all the units have outdoor temperature ratings?
Yes, they do. The temperature rating on our units are -30 to +60 C.
Perfect. And then we did have another question asking if the
Sure.
slide decks would be available. Yes, sir. We will be, Terry, we are recording this and we will make it available for all the attendees. And then also, I know you, Terry, I know your team usually is a pretty big presence at Wispapalooza. So obviously we will be re-airing this if we do have it recorded, but also Terry, feel free to come by the DR booth or the ICT booth and we can assist with any other questions you might have, but we are recording this presentation.
Great, absolutely, Terry. Yeah, I look forward to meeting you at the show next week. That'll be great. Here you can see our modular power series. This is our 1500-watt inverter that he's using to power the routers up here. And then we have a 200 dB 12 distribution panel to provide power to all the separate loads that obviously the site still isn't quite finished yet. But here you can see the backside of the same site. Now, it might be a little hard to follow here, but you can see the AC coming in, the ground lug. You can see the Ethernet cable coming in for communications. And then you can see the outputs. In this case, the negative side is carrying the load, and the positive side is the return. And then these are jumpered together. I know it's kind of hard to see, but the input, this is the battery, sorry, the battery input is here. The negative terminal of the battery is connected here. And then for the distribution panel, then the input of the distribution panel would be negative here and negative here. You can see they're jumpered together. And then the return is the positive side of the distribution panel. And then the inverter is powering the router up here. So here's one of our customers in Texas. They're using the modular power series here. There's 1500-watt inverter, very similar situation here, 200 dB 12 distribution panel. And then here's the MPS Ultra using 4 power modules, 3 distribution modules, and dual string battery management module and inverter up here. Here's a situation using the MPS Ultra, and the breakers, I don't know if they've been installed in here or not, and so yeah, this one is using the outputs from the MPS Ultra to power the loads. Here's a situation where we have our Platinum Series power supply that's providing the power through the distribution panel, the 200 dB 12. In this case, he's not using all of the outputs. So it's usually 1, 2, 3, 4, 5, 6, 7, and these have panels over them to protect from critters getting inside. But if he needs to add any additional outputs, all you have to do is pop this panel off and pop in a breaker and then wire it up and he's ready to go. So this is a picture of what our, when you log into our GUI, this is what you would see. And the nice thing about this is you'd see the battery voltage, you'd see the current, the battery temperature, you'd see the amp hour count. And when the system is running off the battery and the AC has gone offline, you would see hours and minutes here. It would tell you how much your remaining runtime you'd have left. And this is calculated by the system doing battery discharge testing as often as you set it up, maybe once a month. At 2 o'clock in the morning, you'd set the system to run off the battery for an hour. And it would, from that information, it would calculate the state of charge of the battery. That's where this number comes from. And it would also tell you when the system did run, when it was running from the battery, it would tell you what this remaining runtime was. Very convenient.
And sorry, Cliff, to interrupt.
Yep.
I thought I caught you in the middle of a pause.
That's all right.
Other question, the batteries that were being shown, what was their temperature ratings?
Oh, I don't know. I don't know what those specific batteries were or what their temperature ratings are. You know, that I'm not. I don't know what the manufacturer, the battery manufacturer, what the specifications were. But obviously these are telco style batteries, and so they'd be designed for you know, for outdoor enclosure application. But
So I guess a good follow-up question would be that as far as the ICT platform, the battery, as long as it meets the specifications, you guys are agnostic as far as the brand or style of battery, as long as it does everything that it needs to do, correct?
exactly right. Yes. But I will say I have been getting an awful lot of you know, interest in lithium batteries, and the reason being is that lithium batteries are half the size, half the weight, and twice the capacity of a lead acid battery. They also have more than twice the life. So it's not unusual for a lithium battery to last for 20 years. And oftentimes the lead acid batteries are replaced every 5 years. So it's the, you know, it's the cost of ownership is much better with lithium, and their energy density is twice that of lead acid. So there are some lithium battery manufacturers out there that are building batteries specifically for telco applications, and they become quite popular with some of our major customers. And so for that reason, we have upgraded and designed our firmware to be compatible with either lithium or lead acid. So it really depends on the customer. So here's some things as we're getting close to concluding. Just remember that the power requirements for the device should be based, now this is kind of chuckly here, based on the electrical DC watts, not the RF watt rating of the device. So, you know, it's how much power does it need, it's not how much RF power is it generating. So that's one thing to keep in mind. Why do I say this? Because we've had people get confused with the specification. Be sure to follow the manufacturer's installation manual in order to avoid short circuits and damaged equipment. I heard a rumor, somebody told me once that once the smoke comes out, it's really hard to get it back in again. So that's one of the things, and one of the reasons why we do this is to avoid that scenario. So we want to make sure that you guys are happy, that you don't have any failures and everything runs the way it's supposed to. So is reliability and uptime important? Of course it is. And so you should select products that have a failure rate of less than 0.2%, which is what ours have. You should also consider the cost of ownership over the life of the site when selecting a vendor. And here's a quote from one of our major accounts, Metalink in Ohio. And Nathan is telling me, you get what you pay for. We use the Platinum series at most of our tower sites and have hundreds of ICT units in service. I can send you a list of testimonials that are similar to this that fill up a couple of pages. So, you know, you know, you really need to consider the full cost of ownership when you're selecting a provider of DC power. So Here's a quote from Benjamin Franklin. I know he said it because I was there. The bitterness of poor quality remains long after the sweetness of low price is forgotten. Any questions? Comments? Jokes?
I don't. I think you handled the joke part with the Benjamin Franklin one, so I think we're good there.
Okay.
No, but we have reached the top of the hour. Obviously for anybody that is attending Wispapalooza, please make sure to swing by and see us, Double Radius at booth 421. ICT, did you say 301? Is that where you guys are, Cliff?
309, I believe.
309.
Yep.
So ICT will be at booth 309. Double Radius will be at booth 421. If you do have any questions once we end this, please feel free to reach out to either us at Double Radius or ICT directly. We do appreciate everybody spending the hour with us. We hope everybody stays safe, and for anybody that's down in the southeast, I hope everybody stays safe when Ian comes rolling through. But obviously, if anybody has any questions, you know where to find us. Do not hesitate to reach out to either us at Double Radius or the folks over at ICT. We hope to see everybody in Vegas for those that are attending. And thank you everybody so much for joining. Cliff and Charles, thank you so much for leading the way. And everybody enjoy the rest of your week.
Absolutely. It's been a pleasure. Thanks very much for your time.
Thanks,
Thank you,
everybody.
guys. Appreciate everybody.
Okay. Let's see if I can. Are we finished? I think so.